Now, this is the second segment of the Module 2 lecture. In this segment, we're going to talk about summarizing data from a qualitative variable. Data from a qualitative variables are summarized in a frequency distribution. Now, a frequency distribution is just a table that shows the categories of the variable and how often each category is observed, which is the frequency of that category. Here's a very simple example. We have the data that consists of the later grades of 10 students. So we have the 10 students, 1 through 10, and the grade that was assigned to each of the students. All right, to create the frequency distribution table, well, the first thing we do, we list in the first column the variable name. In this case, we're going to call it grade. And we list the categories of that variable. As you can see from the data, we have these categories, A, B, C, D, and F. Then the next step is we go and look at the data and say, well, how many A's were assigned to the students? And you can see there is just one A, so the frequency is 1. Then you look and say how many B's were assigned to the students, and you look through the data, and you find that only one B was assigned. Then it is, well, how many C's were assigned to the students? Then you look through the data and you see that there is 1, 2, 3, 4, 5 C's. So the frequency of a C grade is 5. Then you say how many D's were assigned? And again, look through the data and you find 2 D's. So the frequency of a D grade is 2. And lastly, you say what is the frequency of an F grade? And you look through the data set and you find it only once. So the frequency is 1. Then you sum these frequencies, and it's 10 because you have 10 observations of these 1, 2, 3, 4, 5 categories. So this is the first part of a frequency distribution. Now, the frequency distribution is often extended to include the relative frequency and the percentage. Now, how do we calculate the relative frequency? Well, very simple. So the relative frequency of a category is we take the frequency of that category and we divide it by the sum of all the frequencies. That will give us the relative frequency of each category. Then the next column, we're going to have the percentage for each of these categories. And we obtain it by just taking the relative frequency of that category and multiplying it by 100. That will produce the next column in the frequency distribution table. So here's a continuation of our example. Here's the 10 students and the 10 grades. So this is the same data set that we looked in the example a minute ago. And we already had created the first 2 columns of this frequency distribution. And now we're going to extend it to include the relative frequency and the percent columns. So to get the relative frequency, you divide each of the frequencies by the total number of observations, which is 10. And by performing that division, you get the relative frequency for grades A is 0.1, for B is 0.1, for 5 is 0.5, for D is 0.2, and for F is 0.1. So again, you divide the frequency by the total number of observations, and that will give you the relative frequency. To get the percentage, you just multiply the relative frequency by 100, and then you get the percent. So 0.1 times 100 is 10, and 0.5 times 100 is 50, for example. So again, if you sum the percentages, you will always get 100%. The same with the relative frequency. If you sum the relative frequencies, you always get 1. So this is a property of how we're computing the relative frequencies and the percentages. So this is a complete frequency distribution. So one thing that someone asks you if you present this table is, well, what did you learn about this? Well, I noticed that 50% of the grades were C's, only 1 A and only 1 B were awarded. There were 20% were D's and 10% F's. So if you look at the failing grades, D and F, well, D is not a failure, but if you look at the number of grades, they are towards the bottom of the scale. So you may say, well, this is a difficult class, or this is a difficult professor or a terrible professor. So again, you can draw your conclusions, but this is telling you that most of the grades are on the low end. So be ready, because I'll be asking you to interpret these frequency distribution tables. All right, here's a second example. So a sample of 30 employees from a large company was selected, and these employees were asked to tell us how stressful their jobs are. So the responses, which are recorded over here, were either very stressful, which we'll code it as very, somewhat, which means somewhat stressful, and none, which means their job is not stressful at all. All right, so we're going to use this data, and we're going to construct the frequency distribution for the variable stress on the job. All right, so if you're doing this by hand, the very first thing that you will do is list the variable name and its categories, the 3 categories that we see here. And then if you're doing this by hand and you need to, well, you can put a little mark every time you see the category very, and mark every time you see the category somewhat, and then mark every time you see the category none. So in this way, then you will find that the frequency of the very stressful answer, then you see that is 10 times that appear, somewhat appear 14 times, and none 6. If you sum these frequencies, you get a total of 30. All right, so now we take this counting table, if you will, and we put it onto our frequency distribution. So here is a variable stress on the job, the categories, the frequencies that we found from the data, which they sum to 30 because we have 30 observations. Then we divide each frequency by that total number of observations, and we obtain the relative frequency. So we obtain 0.333 for the very stressful, 0.467 for the somewhat stressful, and 0.2 for the not stressful at all. If you sum these relative frequencies, they add exactly to 1. Now, to calculate the percentages, we just multiply the relative frequency by 100, and that gives us the percentage. So we have the 33.3% of the workers say that they are very stressed, 46.7% of the workers say they are somewhat stressed, and 20% say they are not stressed at all. So now if you are for example, the human resources manager of this company, when you see these figures, you may get worried because you say, well, I mean, a third of our workers are very stressed, and about 50%, or a little lower than 46.7% to be exact, they're saying that they're somewhat stressed. So we may have issues with employees having health problems because of the high stress and the work. So again, that's how you could interpret this and draw a useful conclusion from this data. All right, and these 2 data sets were relatively small. In this example 2, we have 30 observations. In the first example, we have 10, and counting the number of times each category appears is manageable. Now, there are situations where we have huge data sets with hundreds of thousands of values for each variable. And you can imagine that counting every occurrence of each category will take forever, and probably we will be making mistakes because there are so many. In this case, you really need to use a software package. And in modern statistics, we're always using software. In this class, because it's a beginner's class, we don't use software. We tend to use the calculator. However, sometimes I will show you how to use Excel to do some calculations that may be tedious or complicated, or if we ever have a large data set, or to generate graphs. But I listed quite a few software packages that are oriented towards statistics, all of them except Excel. But Excel can do a good job for basic statistical calculations. All right, so now consider this example. This is a large data set. This is a data set from a bank that was assessing their customer satisfaction. In this case, there are 2,020 individual transactions listed. This table over here only lists the first 20 data cases. And in here, we have to use some software package to produce the frequency distribution. So in this case, we use Excel, and using the pivot table in Excel, we can produce the frequency distribution. And here's the name of the data set. I will post this data set for the module 2 if you're curious and if you'd like to play with it. And again, if you are curious as to how to use the pivot table, let me know and I'll be glad to show you. But using the pivot table, we produce this frequency distribution. And you see that there are 1,021 of the transactions occur in New York, 503 in Paris, and 496 in Sydney. If you sum these frequencies, you obtain the total of 2,020 because there are 2,020 records in this data set. If you divide each of the frequencies by the total, then you will get the relative frequency. So you have 0.505 that's a relative frequency for New York, 0.249 for Paris, and 0.246 for Sydney. Again, if you add the relative frequencies, they should add exactly to 1. Now, to get the percentages, you multiply each relative frequency by 100, and you get the corresponding percentages. And these percentages should add to 100. So from here, we can see that 50.5% of the transactions are done in New York, and about near 25% are done in Paris and Sydney, so almost the same amount. So you can see that the majority of the business of this bank takes place in New York. All right, so in the next segment, we will talk about the graphical displays of a frequency distribution.